Thank you for joining the December 13th, 2018 VOLTHA call. We have several demos lined up today. I'll mention that we do record these and post the meetings to YouTube, so keep that in mind during any presentation material and any related discussion as well. And with that, I think we'll start off. Our plan, I believe, for today is to start off with kicking off the ONU software download at the start of the meeting, and that will be the first part of a demo, and then we'll return to that after it's had some time to run in the background. And while that's running, we'll do additional demos. We've got one from North Forge, and then also Gamza will be doing a demo related to some of the work she's been doing in the past sprint. And with that, Lynn, are you ready for me to give you a presentation right?
Yes, I'm ready.
Okay, thank you. You should have it in just a moment.
Okay.
And we can see your screen.
Yeah, you can see my screen. Okay. So, so today I'm going to demo the XGS-PON ONU upgrading procedure with a real ORT and ONU. So this is first off I described the test bench in my lab to test this function. This is can you see my screen with a diagram?
Yes.
It's the diagram is the test bench consists of 3 parts. The first one is the Ubuntu server running VOLTHA, and HTTP server that can be used to download the image file from outside VOLTHA. And next is the ORT itself is running ONL, Open Network Linux, and connected to an XGS-PON ONU with fiber, talk with on-site messages. So this HTTPD, it's quite easy to set up HTTP in the. So I just use a Docker container, download it, and add the ONU image file into the HTTP local directory and map port 80 to 9090. Yeah, this is what I used to test the download procedure. Yeah. Now here I just pre-provisioned the ORT to save time, because it takes several minutes to do the upload and download. Yeah. Excuse me. Any question?
No.
Okay. I give a brief introduce to these different windows. Too many windows here.
No, that's good. That's good.
Yeah. This is a shell that we can see the provision the ORT and the ONU, and the state is in downloaded. And this one actually it's a log to monitor the VOLTHA doc log. And in the middle one, this is the ONT console window. So it display here to show the progress of downloading, because it take 40 to 50 minutes to download. And the bottom one, this is the ONL, Open Network Linux in Open ORT hardware. Yeah, this is the Docker log of VOLTHA. Just for monitoring. Yeah, and so actually the download procedure is quite straightforward. It consists of three steps. The first step is download image file from the HTTP server to VOLTHA with and the second step is to download the image file from VOLTHA to the ONU with on-site messages, and the step is to activate and commit the downloaded image file. So as you know, all the GPON ONU support 2 image banks. We just use the downloaded and upgrading procedure only to the standby bank of the image. It does not touch the active bank.
Good.
Yeah, and so that's why we need to ONU in the MIB-sync state, because ORT need to query the image status of the ONU to make sure it download to the standby. Okay, so there are several scripts, and so let's enter the device ONU. So it's there are several command listed here. We use this one, image download request, and image activate, and image status to monitor. And image download request is to download from the HTTP server to VOLTHA. And the image activate is used to download the image file from VOLTHA to ONU and activate the image. So and the last command is the image download cancel. Because the download procedure take too long time, so if you want to cancel that, use this command.
So
yeah.
So image download request, what you said is from the file server to go to the VOLTHA, right?
Yes. Can you see the diagram now?
Yeah. So
okay. The first image download request is to download the image file from the server to VOLTHA.
And not onto the ONU just yet? No,
because actually in the framework of the OpenOSI, it has defined the image download frame that each ONU can have multiple images downloaded,
right?
And that's saved in the VOLTHA local directory, not saved to the ONU.
Oh.
So that's on VOLTHA side, not sent to ONU, not yet.
Okay.
So if the VOLTHA want to send the image to ONU, you need to activate the image.
Okay.
Mm-hmm.
But so when the image got pushed down to the ONU, you have to activate it. So what I'm saying, the image down to the ONU and activation is the same step. They cannot be separate.
Yes. From the development, it can be separated, but from this predefined command, I cannot find it's not separate, I think.
Okay.
Yeah.
Okay. Continue.
Yeah, and then there is another command is email list. There is a list. There's nothing here, right? So let me check. Actually, I have configured the HTTP server and put my image file upload to that server. So I just demo the download from HTTP server. So the download request that you specify the URL of the image file -n is the name. This is the name. The name is very important here that we will use it for the later image download command. And the D, this is the local directory to save the file, the VOLTHA local directory to save the file. And the V is a version. It's a, yeah.
I have a question about these downloads to the VOLTHA server. If you have 2 or 100 ONUs that share the same image, do you have to download it for each one to the VOLTHA server, or are they shared? Can the file be shared by multiple devices?
Yes. You mean the file downloaded to VOLTHA?
Yes. Can the file that's downloaded to VOLTHA be shared by multiple devices? You went into the device menu to do the download.
Yes, it's saved in the local directory. If in the same container, it can be shared by different ONUs. So firstly, if I specify the download the image file, it will search local. If you find it, it will not download.
So the fact that you went into the device submenu for a specific device just gets you to the commands, but it's not relevant. It's not specific to this device.
For the device, I mean, for the ONU. Yes.
Right. You went into the device for this specific device and did an image download request.
Yeah.
I could later change to a different device, and that image would still be accessible.
Yes. Yes. In the same container. In the same. Yeah. Another. If you change another device, it can, but use the same command.
So if you use the same command, and because if you use the same command and then you still have the HTTP the address, then they will search the local first before to go out.
Yes.
Okay. Chip, you want to say something? Oh, I thought Chip was going to speak.
Yeah, this is.
So,
yeah, go ahead.
So I'm having simple questions. And do we have the only support HTTP only or TFTP?
Yeah, right now it's just the HTTP, but we can add the FTP extension later.
Okay. So how many image size we can we want to download now?
Image size, you mean the file size or the number of images?
Yeah. How many size?
How many size? Okay, size limited. It's just depends on the memory and the resources.
So I wonder is this regarding to the download time. So if an image very large, so maybe this download time very longer. So
yes. It's if download from internet, it could take several. It depends on the network. So in my test, I use an image that is about 12 megabytes. Okay. So yeah, I think that's for an ONU, I think it's really big. But for residential gateway, that's could be reach more than 20 megabytes.
Okay, it is relative to the OMCI the message. It's a kind of the window size, so you can adjust the window size for and when you download the image, right?
Yes, it can. The window size can be adjusted. In the demo, I used 31.
Oh, 31.
It's actually the 32. It's the 32 minus 1. Yeah.
So how much time we can download your image?
In my test bench for the 12 megabytes, it takes about 40 to 50 minutes to download.
Oh, 40. Okay.
Yeah, maybe we improve it later, but now it's just implement the whole procedure of the downloading. We need to figure out the bottleneck of the downloading. Maybe the bandwidth or the communication between VOLTHA and ORT hardware. So maybe we need something to improve later.
Okay, maybe we can and the group downloading to the AVONU. Maybe something happened. Yeah, it something delayed downloading. Okay, I know that. Thank you.
Okay, so after download from the HTTP server, we can check the downloaded file with the download status command and specify the name of that download. And this is the ID, is the number, and the name we specified in the command line, the URL, and the image version, and the last one is very, very important, is the image file size. Okay, so next we need, go ahead.
Yeah, hi, sorry. I joined late, so I missed the initial part. So right now it is getting downloaded on OLD from a file server. Is that correct?
Yes, actually the whole upgrading procedure consists of 3 steps. The first is to download from the server to the VOLTHA.
Right. So when you say it's going to take 30 to 40 minutes, is that the download, is that the step 1, or is it the total download time on ONU?
Download to ONU with OMSI messages.
Okay, so that total takes around 40 minutes in this test, right?
Yes.
Okay, got you. Thanks.
Okay. So next we need to start the download from VOLTHA to ONU. That's very easy with the command. Just after I enter that, the ONU console window has will print out the download parameters, for example, window size and the number of windows, and so you can check. Yeah, this one, the total window is this number, and the window size is this. And the last section is used for internal debug. Now we can check the status. Yeah. You see, everything the same except downloaded bytes. This is a item that's not showed in before. Yeah, that means the real-time number of bytes downloaded to ONU with OMSI messages. We can that's used for monitor the download procedure. Okay, you can see the number increase. Yeah, it keep increasing, and this ONU is just your download procedure indication.
Yeah.
And so that the next we just wait for the end of downloading. Yeah, and this is the ONL. We can check the. Yeah, this is the logging all the OMSI communication ongoing.
that would be a huge log.
Right.
Okay.
Okay. So at the end of the download, the Docker the filter the Docker log, the VOLTHA log. So only at the end of download it will show something. So now just where you can see that's a little bit slow. So I can hand over and the control of the screen. Any question? Yeah, any question?
No, this is good. You know, the first file download we ever seen so far. So this is a milestone.
Actually, yeah. This is a window, one message. You know, let me say download is download window by window, and each window consists of 32 sections. And so if one section is lost, the window will retry. This means the one message lost for any reason. One section lost and the window retried, it's keep going. Make sure the download going correctly.
Okay. Maybe next time when you do a demo, maybe have the ONU actually have a traffic running, and then we can see that. And no, this is good.
Okay. Yes, you just use this command to monitor the downloaded number.
So now basically we just wait. So Julie has you take over.
So I have a question. Hello.
Okay.
This is speaking Jason. So do we have the standard download time for leverage this the image download for?
Yeah, I think it's a good question that we still need some high-level logic to control the download procedure. For example, we need to logic to limit the download timeout and schedule download of schedule upgrading of the ONU in case ONU is not online, and do some error failover for downloading failure. So that should be a high level and orchestrated by some high level application or logics. So far, there's no limitation of the download timeout.
So I see you set up the window size 31. So maybe we can adjust this value lower. Maybe we can download fast. Maybe.
Actually, 32 is optimized parameter. If the window size is smaller, it will add more overhead to the download because each window there will be more windows, and each window need an OpenSI response, but from ONU. But download section doesn't need an ONU, doesn't need ONU to respond to OpenSI. So a smaller window and more overhead, but the retransmitting overhead is smaller.
So if we have the situation is we in a sender network have the multiple ONU download, so maybe it's affect to the window size for downloading.
Yes, it can be tuned ONU by ONU. Yeah.
Okay, I got it. Thank you.
Okay. Yeah.
I also just a quick question. Like I'm seeing in your window, like you have in the window on the left where you have the sudo, you're looking at the logs, and there's unhandled error and deferred. Those are really exceptions.
Yes, this is because I think I saw this error. There's some error in the OpenOMSI, including the alarm and alarm sync, and maybe some I saw this error. Yeah, I saw this error before I start the download.
Yeah. What I meant is like it would be maybe preferable to capture the logs and open a Jira for that.
Yeah.
Because those are exceptions.
Yes. Yeah, I will look into that and figure out what the log.
Okay, thanks.
Okay.
Thank you. Any other questions for Lynn before we move on to the next item? And then we'll come back and check the status of the download towards the end of the call. Okay, next presentation and demo is on the North Porch side. Which representative should I give the presentation control?
Myself, Gilles.
Okay, let me find.
Hi, Julie, George here. I'm here too. So Gilles will do the presentation. Thank you very much for giving us the opportunity. Thanks, Gilles. You have the floor, I think.
Great, thank you. And you should have the presentation rights.
Okay. Oh my God. So, do you see my screen?
Yes.
Yes, we do.
Okay, good. Okay. So today I'll talk about be talking about test automation, where we currently stand, and the next steps. So the agenda for today, we'll look at the test automation framework, the details. Then we'll look at a current test in Jenkins, what it does, how to find the logs and the results, the location of the code with a quick overview of the files, a troubleshooting example, and known glitches to look out for. And then we'll follow through with the roadmap. Okay, so this is the block diagram. So what we have it uses robot framework for test case. Just let me put something out of the way here so I can. Okay. That's better. Okay, so it uses robot framework for test case execution. It uses Kubernetes for current set of Helm charts for test environment. It runs on a single node, and it evolved from Ciba in a box, but with just the essential elements. So that would comprise VOLTHA, ONOS, and PONSIM v2. So XOS and NEM have been left out. So all the tests are invoked using VOLTHA and or ONOS CLI. So it uses locally built Docker images, or eventually on demand, for failure isolation, we might use Docker Hub images. So it's currently running as a Jenkins job, triggered on Gerrit code patch delivery as part of the auto test verification. So that's the breakdown.
Any questions?
So, yeah. No. Okay, so I'll carry on. So the Jenkins service, that's used to communicate with the slave test node running on a dedicated server. It manages jobs triggered by code patch substitution to Gerrit. It'll control the job pipeline through all its different steps, and it manages all testing artifacts published after the job is run. The slave test node, which is the main one. So the robot framework project is composed of the following sequential procedures for each test case. So it clones the automated testing repository along with the user patch. It builds VOLTHA, ONOS, and PONSIM v2 Docker images. Then it will deploy those using Helm onto a Kubernetes cluster for VOLTHA. So it'll run the robot framework project afterwards, and it'll kick that off. and the VOLTHA cluster is just a node is recreated and torn down for each test run, but it's that's for each test suite run. Yeah, but we have just a single test case for the moment. Test management runs the test. It uses SSH commands, wrapped by Python functions, and pexpect library calls. And each test case has success or failure return codes. In case of failure, the whole test is rejected. So it fails on the first instance of a test failing. So at the end of the test, all relevant logs and robot reports are published to the Jenkins service. So that just gives you a highlight of the time breakdown and the different steps in the pipeline. So there's a cleanup at first. It gets rid of all the the first logs that have been reported for the previous run. It does. That's a VOLTHA repo, so that's where it brings in the user patch, and then from that it builds VOLTHA and ONOS, and that takes about roughly 4 minutes. Then it starts the actual runs the test case. That's it's about 9 minutes, but that includes both the deployment of all the pods, and then tearing them down at the end. And then there's a publishing phase, which all the artifacts are pushed to Jenkins Service, and I'm not really sure what the last one is all about, but it's minor. So the execution of a test suite. So like I said, there's a startup and shutdown phase included for the test suite. I keep repeating, but it deploys all the Kubernetes pods, and at the end it tears them all down. Mm-hmm. Each test case is invoked one after the other, building on the previous one. All pod logs as well as test logs are being collected as testing artifacts, and robot will generate its own artifacts, and again all of them are going to be going to the Jenkins service at the end. So that's a view of all the pods that get launched, deployed before the test begins. Mm-hmm. Okay. That's an example of all the log artifacts that are collected. The majority of them are for the pod logs, and then there's test logs as well. I guess they're preceded with VOLTHA at the bottom, so that's mostly what we run, but that's associated with the first test case.
So for people interested or something like that, probably the VOLTHA related log is the most important ones, right?
Yeah, that's the test case logs. Yes.
Okay.
Yeah, but they may change. I mean, the names might be mixed in with the other ones. If once I do like the authentication, they might. Well, I might use the term VOLTHA authentication, maybe, if you want, just to keep them all together. Yeah, and isolated from the pod logs.
Is the log is native to the VOLTHA log? You just copied it over, or is actually?
No, these are our logs. Okay. These are logs produced from the test case themselves. So CLI, so all the CLI commands and everything that gets reported back from the CLI command gets put into these logs.
Okay.
So we'll look at these logs afterwards once I get onto Jenkins, just for give you an idea.
Okay.
Robot, for people who are not familiar with robot, these are the two. Well, that's one of them. This is the log report that it produces. So you can see it breaks down. And so over here, there's the test. So it's provisioning. That's the name of the test that we have currently running. And these are all the different steps that it does. So like I say, there's a setup for all of starting VOLTHA, and there's one to stop VOLTHA at the end. And in between, it's actually the test steps themselves. And you can, open these up, and you can see briefly what the brief status of the success or failures of the test case. I guess it's more important when it fails, not so much when it when it passes. And then when you get an all green, that's a good sign. This is the overall. That's the test report from produced from Robot. And you can dive into the our individual tests themselves, but we just have the one. So, yeah. Okay, so as far as the code, so that's located in under VOLTHA test and A test, for A for automated testing. So these are the files we have so far. So if we start with the ones under common, so these are all mostly the Python files. So what we have VOLTHA, that's everything associated with starting and stopping VOLTHA. And we have a utilities file for Python calls. And then we have a file for each test case. So we have pre-provisioning and discovery that's on its way. Auto test, that's just the overall cleanup and shutdown of the whole script itself. Run robot, so that's what robot actually calls. So the VOLTHA test suite calls run robot to start the whole sequence. Then under builds, what's most important is the make file. So that's the one that we kind of inherited from CBA in a box, and that we've adapted for our automated testing. And then there's a few JSON files. These are files that we have to push to ONOS because there's discrepancy in how CBA tests for various things and uses ONOS, and we have to make changes to the net config, just slight changes to get VOLTHA to go. And under robot, the most important file is the VOLTHA automated test suite. That's the robot file, and then the other three files are generated files. Okay, let's move on. So troubleshooting. So the thing is to locate the test that's failed. So that's in the robot log and report. So each test will have a short status explaining pass-fail information. So I guess you focus on the one that has failed, and then in association with that, you look at the pod logs are there to help you as well, and then the test log artifacts as well. One thing to ensure is that that all the pods got deployed correctly and were in running state before the test case were run. So you get that from the Jenkins console output. Known glitches. So we initially had lots of build issues, but those have been resolved. On occasion, like I point out, not all pods get deployed properly. So check the logs for that. And we
do you actually automate the checking of the console log automatically, and then you stop the test case? Or I would guess the robot would check it, right?
Yeah. Well, tied in. Yeah, so Jenkins is kind of tied into everything, and so yeah, we don't stop the test if all the pods are not deployed correctly. Yeah, that's
okay.
Yeah.
But it's not a manual start, right? It's a Jenkins. So who started the test?
Okay. So the test. Okay. So we were using manual starting at initially just to get and to test the environment and get things going. But right now it's been it's part of the auto testing that Jenkins does. So it's triggered by any patch that gets delivered to Garrett. And upon that, I guess there's 3 elements that that gives you a +1 from Jenkins, and so we've been added to that list. So there's unit testing, and then there's the licensing, and then there's us now, the auto testing.
Okay.
Okay.
So Jill, it is triggered by any code review that get +1 rating, not because of the actual commit, but just some code review getting into +1.
It generates the +1 in association with the other 2. So if any one of the 3 that I've described fails, one being us, then Jenkins will not give you the +1.
Oh, okay, thanks.
Okay. We'll see that when I open up Jenkins there after this. So for monitoring, I guess at the moment, I guess myself and Kailash are on the mailing list for failed job runs. But we need QA to take a leading role in providing assistance to users that are concerned that this is failing for no reason of their own. But if any questions arise from QA, then we're there to help out.
Yeah, I have a question because one test fell, then we will not be able to detect other problem, right? So if that issue look like a blocking issue, if your test fell, then we need to make sure that the problem is fixed as quick as possible. So we need to put a process in place to solve the problem that caused the test failure.
Yeah, true.
So my question is for the whole group here. So can we have a process in place? For example, somebody need to create a Jira ticket and assign to the owner of the commit that caused the problem. Sean, do you have any comment on that?
I think so. Definitely, when you mentioned QA, right? So is the QA? One thing I'm wondering is QA from the VOLTHA team, or is the QA in the ONOS, in the ONF? ONF has a QA team, right? So maybe this is something we can discuss in advance, in addition with the Kailash, and regarding to the Open Jira, things like that. So Daniel, can you repeat that question? You're expecting the QA team to issue the Jira or
Yeah. So we need to have a clear role and responsibility. Otherwise, we cannot solve it. We don't have a effective process.
Right.
We have a tool right now, but the missing thing is a good process, and we need to think about that. I don't have to have it now.
And I think we can definitely work with you to establish that process. Also, I think right now, just Julia and I don't think we have a actual process in place for this project just yet.
No, I don't think we do. Yeah.
So,
Daniel, sorry, just one comment. I think because it runs on every commit before it's submitted to master, we should not have the problem enter the master branch, right? That's the whole point of this.
Right.
No, but when you have a failure, who will fix that? And if somebody doesn't fix that quickly, then somebody need to push that, right, for the fix.
Right, but I mean, we should catch it as before the commit goes into master. So the owner of the commit will be notified right away that there's a problem. And
I see your
right?
point. Your point. Yeah.
I mean, maybe somehow it gets introduced by another commit, but since it's checking every commit, once we have the branch working fine, it should technically catch it as soon as something is broken, right?
Yeah, but what I experience is when you before the commit you don't have problem, but after the commit you have problem. Right? So in that case, what to do?
And we just have then before commit. Okay. So George and Daniel, let's walk this through, and study the process how we can do, right? So
right.
To be honest, I know whenever there's a code, the Jenkins will do the testing. That's on the open core Jira side, right? But your scope is much more system. You are doing the let's get together sometime soon, and then see what we can establish. Definitely, there's something if something's wrong, because right now I think something not working. It will probably take a little while to discover, right? And then people open Jira, for example. But I think with this process in place, at least some of the issue after commit will be discovered right away. So what is the what's the, do we run this every day, or is there something so the duration of running the test case, and also how often we're going to run? I think that is something. Let's discuss this offline, since Julie have a third demo need to do also. The process definitely is important. Yes.
Yeah, but right now, the process has been automated, and the onus is on the user submitting, code. That if there's a failure, and if it's not, our test cases, the integrity of test case has been proven, then it's up to him to fix the code such that the test case passes. It's something that he's broken. And he will realize that as he goes through, he won't be getting a +1 from the Jenkins approval side. So he'll be able to identify, that it's ours, and then he can step into the like I just into the robot reports, and then try to identify what it is that is failing, and have him focus on, and we have the pod logs, and we have the test logs. And then from that, he can acquire more information as to, what it is that the change that he's made that's caused it to fail.
Yeah, that would be great, but my concern is in some corner cases go to the commit, and
so it's merged. When you mean commit, it's been merged. Okay, so it's passing, and then but there's some. So we're not catching everything, that's for sure. I mean, we're just putting, we've just got a single test case at the moment, but as we've defined 6 test cases. That's in the next slide. But
and also right now the test setup right now we have just the pound sim, right? So some of the bug may related to the real the devices or the OpenOT adapter, right? So I don't believe the pound sim is using the OpenOT adapter today. Maybe later on we can use BBSim, potentially.
Yeah, true too. Yeah, and that's into the next slide. Yeah, the roadmap.
Okay. So let's move on, and then George and Daniel, let's get together, and then other people in the community have the interest of this one, we can have a separate discussion.
Yeah, when we feel that we have a good proposal, then we can come back and discuss.
Yeah. Thanks. Great. Yeah, we'll take this offline. Thank you. Thanks for raising.
So that brings into the roadmap. So we have 5 test cases planned. I guess I said 6, but one's been the future for related to multicast, which we're not sure where. Yeah, it's been postponed to VOLTHA 2.1. But anyway, so we have 5 test cases planned. So OLT provisioning and enabling, that's done. That's what's running right now. ONU discovery, that's in code review. And then the next 3 are authentication, unicast, flow setup, and DHCP. So we plan to complete all these test cases by end of February. So we've included some contingency there where we need close collaboration to resolve unexpected issues. For instance, the one that we raised on for ONU discovery there about the disparity in security between ONOS and
right. Okay.
Yeah, so that one we've raised. So we need a solution on that quickly. So for future, for multicast, then we'll have another test case, and then PONSIM. We're using PONSIM v2 right now, but there's proposition to use BBSIM, and ultimately support for physical OLT and ONU.
Please go back.
Oh, sorry.
Please go back. I have a question is authentication. And why you using authentication? Is user number or registration ID?
Sorry.
What kind of your authentication?
Authentication. Oh, well, it follows the existing authentication test that's on the Maple list. So it's.
I think the radius authentication.
The radius authentication, yes, exactly, radius.
Basically,
radius.
based on AT&T's workflow right now.
So I wonder is we have the Jira ticket regarding registration ID. So I think about relative is the issue.
Okay, something else. Yeah, no. Yeah, so it's radius authentication, yes.
So on your discovery, so you on your discovery, you using serial number only or registration ID? Discovery.
Well, we're looking at ports, we're looking at flows, and we're looking at on the ports of the peers that there's a match between the OLT peer and the ONU peer.
Oh, okay.
Yeah, well, we're doing it at that level. Yeah, it's.
Okay. Thank you.
Yeah. So. Yeah. So for reference, there's a high-level design that was recently updated, and that's where it sits. Do I have time to go maybe onto a Jenkins and maybe show a few things?
We've got about 5 minutes.
Oh, that would be
then
probably
I need to hand it over to Gamza. Okay.
Okay. Yeah. So, let me see. Oh my God.
And by the way, nice seeing you guys at ONF Connect last week.
Thank you. Yeah, same. It was great to meet everyone. Appreciate it.
So there's actually a test going on right now. So I guess based on code submission, but so the blue are the good one. So let me just go through a good one. So you see, that's the report. That's a high level. You see, you get a Jenkins test log. You open up, and then you can open up the provisioning test. So setup. There's different test steps for the setup, but then the key focus is the test itself. So. This, for example, you see success. that's what you're looking for the when you're doing the pre-provisioning, and also success when you're doing the enable. You know, that should happen all the time. Okay. Oh, was there a question? Yeah, I'm going.
No. I said okay. Sorry. I like to make noise too. You know, someone's responding.
Okay, so I just wanted to focus on the artifacts, the logs. So pre-provision OLT. So that's just the success. But so the device, we inquire the device before the enable, and that's what you see. Which is, people are used to that, and then after the enable, that kind of stuff. But if we had, there's a little bit more when we run the discovery test. There's actually more logs produced then, but that's not running right now. We just have the first test case. So that's about it. Okay, let's look at one quickly. The one that has failed, for instance. Not sure why, but. So, see if it's us. Hard to say. It's supposed to be VOLTHA at local host. I haven't seen that. I don't know why. So it's possible. So let's look. Maybe not all the pods got deployed. Gotta go one more. Console output. They're near the bottom. Oh, wow. There's only, they're certainly not running all of them. I don't understand why. Not everything got deployed properly.
Okay.
Yeah. Anyways, so those are the things. Yep.
Okay, a quick question. So what? Where is this platform? It's on your location, right? So when someone committed or submitted a code or something like that.
Oh, that's what you want to see. Okay, so let's go at the Garrett side. Yes. Okay.
No, I didn't want to see it, but I have the question.
Yeah, but you want to see triggered by Garrett. This is the thing. This is, for example, the change. Okay, so this one submitted this change and it triggered our bot. So the thing is, that's lots of unstable. Okay, patch set unstable. You see? So the unit test passed, the license portion passed, but our test, it says it's unstable. It did not pass. And you can go. That was, well, there might have been several patches here, to try to resolve the issue. But let's say this is triggered job number 318. So if you go just to listed 318 was this one. So this failed. So I guess it's failed quite a long ways, and it, related probably to it. Then it finally passed.
Gilles, one question: if it's something that it was a glitch for not being able to deploy, is it possible for the submitter of code to re-trigger the Jenkins job?
I think so. I think there is a way to retrigger. I saw that somehow,
okay.
But I'm not sure. I don't know exactly where it is now.
Maybe something
I'm not sure most of the code contributor actually retrigger.
Yeah.
You can just say recheck. That's what I have been trying to do. I think.
Recheck.
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 Oh, recheck. That's the one. Yeah.
Bottom of that one. Yeah.
Okay. Yeah. Recheck.
Okay.
Yeah. Yes, that's how you do it.
Okay.
Okay.
All right.
Thank you. Thank
you,
George.
welcome.
Thank you, Daniel.
Okay.
All right. And if we have additional follow-up questions, we can cover those if we have more time. But right now, I'd like to hand it over to Gamza. Gamza, are you ready for me to give you presentation rights?
Yes.
Okay. And Jill, thank you for your presentation as well. Gamze, you should get rights in just a moment.
Okay, can you see my screen?
Yes.
Yes.
Okay. Hi everyone, this is Gamze from Netsia, and I will try to present a demo about my ONOS changes on bandwidth profile and technology profile. Basically, it will cover only ONOS part, not VOLTHA. I will show new studies configuration that includes bandwidth profile ID and technology profile ID, and also I will show new flow mode and meter mode messages to support this configuration. As you know, Sean Misset created a technology profile document, and it includes some flow examples for both upstream and downstream directions, and they are for AT&T and Deutsche Telekom use cases. And I will show actually these flows in my demo, and my related tasks are 732 and 949. In my demo setup, there will be only ONOS and Mininet. I will not start any VOLTHA instance. Sorry for that, but currently VOLTHA core implementation about technology profile is not finished yet. It is in Git review. So VOLTHA currently doesn't support write actions type of OpenFlow and also meters. It doesn't support them. So when I send my new flows, their states are pending at, not added. So I will not use VOLTHA. I just use Mininet for my topology to simulate OLT and ONT devices. This simulation, of course, is not like BBSIM or PONSIM. It just, as you know, when we use a VOLTHA instance with PONSIM, BBSIM, or I don't know, with a real OLT device, we see an OpenFlow switch and an enable port of the related the related OpenFlow switch for each ONT. And sorry for the background voice. Do you hear that? Hello?
It's fine. We can hear you
okay.
fine. Just a little background once in a while.
It's fine. It reminds me of my vacation in Turkey, so that was great.
So to show my ONOS status, I actually need an OpenFlow switch and 2 ports. So please assume that this OpenFlow switch is a logical representation of a real OLT, and its one port is UNI, and the other one is NNI. And also, please note that I changed the switch type in Mininet. By default, Mininet OVS switch does not support meter mode messages. So I installed user switch. Maybe you heard before of soft switch, and it supports OpenFlow meters, and also it can send meter statistics to the SDN controller. So it works fine. And my last comment before my demo, I will show 3 cases. First one is currently used one. Without bandwidth profile and technology profile. I will show it for backward compatibility, and the second one is for AT&T use case, and the third one is for Deutsche Telekom use case. And also, I documented all of this demo, all of these steps in a README file, and you can find it in my Git review. In my virtual OLT Git review, and its Jira task number is 949. So let me start the demo. Okay. First of all, I started ONOS, and it's ONOS log, and its version is 1.13.6. But as you know, currently VOLTHA uses 1.13.5, but I'm not, because I updated OLT pipeline code to support meters. I mean, any VLAN value match criteria and also write actions. So I will use this version. After that, I started Mininet using user switch, and this is my ONOS client. So let's check devices. Yes, there is one OpenFlow switch, and please assume that this is OLT, okay? And its ONOS driver is PMC OLT. But Craig Lutken asked me that can we use VOLTHA driver instead of this one, because he said that currently VOLTHA driver is used in VOLTHA deployments. So I checked ONOS code, and I can say that both PMC OLT and VOLTHA drivers are using the same same driver code in ONOS. And right. Also, I tested my changes both using PMC OLT and also using VOLTHA, and they both works, no problem. But I used PMC OLT in my demo. And let's check ports. You see 3 ports, but the local one is not important for us. It's for its Mininet thing. And the port 1 is UNI for me, and port 2 is NNI, okay? It's a simulation, sorry for these names, because I know that if it is a UNI port, it's the serial number of ONT, but we will see like this because of Mininet again. And at this moment, I want to say something about ONOS applications. Let's see. Yes. In this demo, I'm only using SADIS and virtual IoT applications, and I did not start AAA because sending technology profile ID with the first flow, I mean with the trap flow, belongs to another task. And if I'm not wrong, its number is 1093. And after these tasks, I mean, SADIS and virtual IoT reviews are merged, I will start to implement it. So let's start from the first use case, the backward compatibility. First of all, let's check the SADIS configuration. Yes, this one, the SADIS configuration part. As you know, SADIS configuration can be got from a remote server, or we can use local data, especially for our local tests. And I tested my changes using both of them. I mean, using remote server and using local data, and both of them works. But I will do my demo using local data to show you very well. And let's check this configuration first of all. I think this is the basic configuration. It means you can see CTEC, STEC, and also UNI port name. And it doesn't have any bandit profile and technology profile. So I think you have already know this configuration. So I will add the subscriber to OLT. Sorry, I will clear it to show better. Yeah. Add so OLT to UNI port. Okay. Let's check flows. Oops, reading from this can be hard. So I want to show this file. Yes, it's more readable. This is the same configuration, and these are the flows. So for upstream, in the first flow, this one, I mean, this is the ONU flow, and we add CTEC S2, and we send the packet to the table 1. It means we send the packet to the OLT. So for the second one, we add STAG and we send the packet to the NNI. And for downstream, actually the reverse operation is done. We pop VLAN, first of all, STAG, and after that, we pop the second one, and we send it to UNI port. So I think this is the known version. So let me show you the second one, the AT&T use case. And to show everything clear, first of all, I will delete my subscriber and update my configuration, my SADIS configuration, okay? So let's delete the subscriber. Let's check flows again. Only trap flows. My flows are gone. And I will update the configuration. Not this one, with this one. This is for AT&T use case. And let's check the new SADIS configuration. Okay. Yeah. This is a huge one. Yeah. This is the new SADIS configuration. Oops, sorry. Yeah. This is the new configuration. Now, SADIS configuration has two parts, bandwidth profile and SADIS subscriber information config, and their integration points can be different. I mean, if we use remote servers for bandwidth profile, we can use a URL for a remote server, and we can use a different URL for subscriber information. And also for the SADIS code, each of them, I mean, bandwidth profile and SADIS configuration, has different and separate and unique cache mechanisms. And now you see all information here because of the nature of the local configuration. So let's check the SADIS config parts. First of all, I added the bandwidth profile part. This one is new. And it includes bandwidth profiles, and they can be used for downstream and upstream. My entries are one is for downstream and one is for upstream. For example, this one is for downstream because it only includes committed information rate and exceeded information rate, but upstream one includes also assured information rate, and assured information rate will be converted to fixed bandwidth in VOLTHA, and we use fixed bandwidth only for upstream direction. And all of these values are in kilobits per second. And to say these values to VOLTHA, I'm creating a meter mode message, and each of these items is a meter band. I think for more detail, you can check your Sean Miset's technology profile document. It's a really good reference to understand their details. And for the second part, I mean the SADIS part, subscriber part, it is the actually extended version of the previous one. I mean, I added technology profile ID, and I also added upstream and downstream profile IDs. And please note that I used 10 here, but it is because of the limitation of user switch of Mininet. Actually, its value is between 64 and 255. Okay, but I'm using 10. Sorry for that. It's a little bit confusing, but it's because of the Mininet. And okay, I think we can add the subscriber. But if you have any question, you can ask it. If you don't, I will add the subscriber to this device and to UNI port. First of all, I want to show meters. Yes. We have 2 meters. One is for upstream and one is for downstream, and they are set pending at now added. And actually, these include bandwidth profile values these rates are belongs to bandwidth profile, and each meter band, I mean this one, this one, this one, represents a type of bandwidth. I mean fixed bandwidth, maximum bandwidth, or anything else, and their type is drop. I think it is not important for VOLTHA. My other option is using DSCP remark regarding to OpenFlow, but I choose drop, and it works. It's no problem. And let's see the flows. Yes, reading from this heart, but their state are added. And let's check my file. Yes, this is the same configuration. And here the flows. These are flows. For upstream, this is the first one. I mean, this is for ONU. And for this, we again push CTEC, and we send the packet to table 1. I mean, we are sending the packet to OLT. But OLT flow is different now because we add STEC, but we're using technology profile ID here, and also we're using the upstream meter ID. And also the major difference is for current on-off usage, the output is in immediate actions, but now it is in deferred actions. And it means when we use it in immediate actions, it means that it is a play action. But if we use it in deferred, it means it's a write action. And it means that first of all, at the STEC, and after that, use technology profile ID and use quality of service, and finally send the packet to the NNI port, okay? And for downstream, this is the first flow, and this is the OLT flow, and we pop the VLAN and go send the packet to the table 1. I mean, sending the packet to ONU. And second one is for ONU, and also it is different. We pop the VLAN, and we are also using technology profile ID and meter. And also, we define the output as deferred, I mean, as write actions, and it will apply finally. So I think that's all for AT&T use case. So let's go to the third case, the Deutsche Telekom use case. So let me delete the subscriber again. Yes, and I'm updating the configuration. Yes, this one. So let's check this configuration. Actually, this is the same configuration, but the major difference is CTEC. I mean, 1496 is any VLAN value. So the packet will come a VLAN, and it can be 10, 9, 0, 5, but it must have a VLAN. So let's add the subscriber. Yes, let's check meters. I used the same values, so we have 2 meters and with same meter bands. Let's check flows. All of them added. Let's check my file. On this configuration. Oops, sorry. With any VLAN. And let's check flows. For example, here, yeah. For upstream flows, here there are 3 flows, okay? And the first one is if we get the packet without a VLAN, we drop it. It's no action, okay? And the second one is we waiting for the packet with a VLAN, and we send it to table 1, and we don't push any VLAN. And for OLT, we get the packet with a VLAN, any VLAN. We add a stack as a queuing queue, and we also use technology profile ID and also use meter. And finally, we send it to NNI port. And for downstream, this is one for OLT, and we get the packet with a stack, we pop it, and we send the packet to ONU, sorry. And for ONU, this one, we get the packet with any VLAN from OLT, but we don't pop that, and we send it to UNI port. But before that, we use technology profile and quality of service. So that's all.
Can I have a question, please? Can I have a question, please?
Yeah.
So for the upstream, I see the meter and technology profile is on the second flow or for the OLT part, right? That's fine. But for the downstream, why the meter, the quality of service part and the technology profile is on the ONU side? For me, it's more logical if it go into the OLT side, because we need to do the traffic shaping there in the OLT.
Actually, I don't know how Girish will use them in VOLTHA. I mean, for shaping for OLT or ONU. Maybe Girish can answer that. But for ONO side, the flows are installed like this.
Okay.
Yes, Girish here. So there are some discussions on how to handle this. So the initial expectation was the first flow that arrives at the OLT will have it. That is the EA-pole flow. And that is something KAMSA is going to take up next. So until that Trojan is there, we have to cache, we have to, for example, to handle the EA-pole flow, we have to install a default profile. And once we actually receive the technology profile table ID, we remove the default technology profile and install the technology profile that is actually coming in the flow. So this is the approach that we would like to take. But yes, that is going to change once the EA-pole flow itself starts carrying technology profile table ID.
So you are saying that after the EA-pole authentication, the technology profile and the meter will go to the OLT instead of the ONU?
Yes, so the OLT is going to create the technology profile instance and share it with the ONU.
Okay, thank you.
Any question? No?
No, Ganta, this is great. You're so well prepared and very, very clear indication. It's a good lesson for me. So that's good. Thank you.
You're welcome.
Any other questions for Gamsa?
Yeah, I have a question. Thanks for the demo, Gamze. You showed us two different demos, one for AT&T and the other one for DT. Did you need to implement different things for these two different workflows, or we are using the same implementation?
We are using same implementation. Only our configurations are different. I mean, the difference is only CTEC value.
Okay, so when we introduce the Turkish Telecom's workflow, nothing will change, right?
Yes, but for Turkish Telecom, the configuration will be different from them, because this is for just, I mean, high-speed internet access. But for Turkish Telecom, we use 8 services such as IPTV or voice over IP, and for each of them, we will use different upstream and downstream bandwidth profiles and also different technology profile IDs. So there will be a list here. So I will change the implementation actually.
Oh, okay. Okay,
Yeah.
thank you for
Any other questions?
And also for AT&T use case and Deutsche Telekom, they are using one T-count with multiple jump ports, but for Türk Telekom, we will use one T-count and one jump port for each service. So actually, we will change also VOLTHA. Not only on us.
Okay, I see.
Any question?
No, thank you, Gamza.
Okay.
Great, thank you. Lynn, let me check. Are you able to switch back now to take a look at the status of the ONU download, software download?
I'm stopping.
Yeah. Yes. Sorry. Yeah. It's the downloading still ongoing, not finished yet. I just sorry. I just scenario during the download, and so cancel it and restart. So it's now the downloading is going on 90%. 90%.
So probably we don't need to switch back to you at this point then, unless there's anything else you need to show related.
Yeah. Okay.
Or
maybe do maybe do a screenshot later,
yeah,
and then just send it on the VOLTHA Discuss.
Sure. Sure. Yeah.
Yeah.
Okay, that's a good idea, Sean. Thank you.
Yeah. Good.
Okay.
Thank you.
With that, then let me go ahead and the controls back myself. And hopefully, oops, I just closed up what I was trying to show. Are you seeing the agenda?
Yep.
Okay, so I think that wraps up today. Thank you to all of our presenters. I know we had a tight schedule to fit it all in, so I appreciate everyone for working with that and good dialogue and questions. I think that will wrap up today's call. Just a reminder that Sprint 11 closes at the end of day tomorrow. And so just try and get into JIRA and provide updates. And Garrett, also, if you're doing some code review or things that you're working on merging in, and we'll see how things wrap up for Sprint 11. And then next week on Tuesday, we'll be working on some planning for Sprint 12, and we'll kick that off. The placeholder is available for you to move stories into as needed right now as well. And with that, I think we'll close for today. Last call for questions or comments before we drop today's bridge.
Yeah, Gunther, if there's any delay on the code review, let us know. We'll work out to get those code in place.
I will update them today or tomorrow, and you can merge them tomorrow for your tomorrow.
Okay.
Okay, thank you.
Thank you.
All right. Thanks, everyone. I'll stop the recording.